Off mic off mic. Yes.
你要等一下，他们还在 Cammy 里面。
Okay, never mind. If let's say like this, then 以后3:45了啦。
他们在里面还在讨论这 Cammy，等一下要完了最后一题。
Cammy 你们用什么 ？Google Meet 啊？
没有，也是用 Zoom。
哦。
所以刚刚 last minute 的时候啊，他就直接关掉。
哦，然后又再
你知
on。
道直接关。
哎，等下 later on 啊，every 40 minutes also they will off one 啊，it will off one 啊。So you join back.
OK。
We wait another. I got 2 Oma one. This one no need to copy. I just revise previous lesson only. Hi. Afternoon. Okay, I think who else is not here yet? Anyone else? Off mic, Christina? Yes. I think all should be here already, Kwa. Shavita? Tarani? Matili, they all went to go to what chemistry class or not? Hello, anyone?
Class end already lah.
Off mic, use chat. Okay, then I think we start already lah, huh? Okay, we start already, yeah? Okay, so today we will do 4.2, okay? But before that, I will revise a little bit 4.1 lah. Okay, 4.1 is about thermal equilibrium, okay? It's about thermal equilibrium, okay? So for thermal equilibrium, okay, what will happen is, okay, when two objects, which is different temperature, object 1 and object 2, are meeting together, come into closer to each other, they will have what? Thermal contact. So then this thermal contact, during the thermal contact, there will be a transfer of heat between these two objects, from object 1 to object 2, object 2 to object 1. But depending on which temperature is higher, okay, if let's say object 1, the temperature is higher, means that it has more heat. So when it has more heat, the transfer of heat will be more to object 2, whereas 2 will be lesser to object 1. So there will be a net transfer of heat, okay, during thermal contact. Okay, when the thermal contact happen until reach a certain level, which we will call it as thermal equilibrium. Okay, thermal equilibrium. Okay, thermal equilibrium. Both these object has reached thermal equilibrium. Okay, when it reached thermal equilibrium, it has two condition. Okay, to be said that these two objects have reached thermal equilibrium. So what is that? The first one. The first one is their final temperature will be low. Yes, will be same. Okay, will be same. Okay, so means that maybe this one, object 1 initially is 60 degrees Celsius. Then this one, object 2 is maybe 3 degrees Celsius. Okay, one is hotter, one is cooler. So there is a transfer of heat. Okay, then until it reach thermal equilibrium, maybe this one will become 30 degrees Celsius, means that this object 1 has cooled down already. Then object 2, it will warm up, become 30 degrees Celsius as well. So the final temperature for both will be the same. And yes, Jen, there is the transfer of heat between object 1 and object 2, since both of them have the same temperature already. So both of them, the transfer of heat between these two objects will be the same. So there is no net transfer of heat. Okay, so this is what we have learned for thermal equilibrium. And thermal equilibrium has a lot of application. Okay, for example, your oven to heat up, to toast a bread. Okay, then a fridge to cool down drinks. Okay, and one more is to measure what? Measure your body temperature using what? Thermometer. Okay, so this is what we have learned for our chapter 4.1. So now today we will look into chapter 4.2. Okay, clear? Okay, so I will show you the screen now. Okay, and everyone can see the screen already, ah? Okay, good. Okay, so now for this today, we will talk about specific heat capacity. Okay, so specific capacity happen in our daily life quite often. Okay, so like for example, okay, why is it okay? Actually, I have what I say. Okay, you see this this is a bowl of porridge. Okay, a bowl of porridge. Okay, so how do you the porridge is very hot for you to eat it. So how are you going to solve this problem? Okay, maybe one of the choices you will take some of the porridge into a smaller bowl. Why into a smaller bowl? So that it can cool down faster. And why is it can cool down faster? Is actually something related to specific heat capacity. Okay, specific heat capacity. Okay, so you see here, I think I better. Okay, so for specific heat capacity, what happened is this is an object. Okay, you see the blue one is an object. Okay, the object initially is 30 degrees Celsius. Okay, 30 degrees Celsius. Okay, when we provide it heat, okay, when we provide it heat, what will happen is this object will absorb the heat. Okay, when it absorbs the heat, what happened to the temperature? It will increase or decrease? Yes, it will increase. Yes, correct. It will increase. Okay, why is it will increase? Because the object has absorbed the heat from have absorbed the heat. When it absorbs enough heat already, okay, and maybe a certain amount of heat, then it's able to increase the temperature by maybe 1 degree Celsius. Every absorption of heat, it will increase another 1 degree Celsius, absorb a certain amount of heat, increase another degree Celsius. So the heat that is absorbed by the object to increase the temperature by 1 degree Celsius, that will be, we will call it as heat capacity. Okay, heat capacity. Okay, so heat capacity can be explained more furthermore by using this diagram. Okay, so you see these two diagrams. We have diagram, two beaker will be the same. Okay, the volume is the same, just that they have different amount of water. Okay, one, the left hand side is more, then the right hand side will be less. Okay, in your opinion, okay, never mind, I already say here already. Okay, so greater amount of water, okay, which means that it needs more heat to absorb more heat in order to increase the temperature, right? So greater mass requires greater amount of heat. So we will say that the water in the left hand side, okay, will have higher heat capacity on the right. Okay, why is it so? Because greater mass, it needs greater amount of heat to increase the temperature, okay, so that it can reach the boiling point. Okay, so this is what a heat capacity does. Okay, the heat capacity definition is. Okay, so I want you to write this down as your notes number 1. Okay, heat capacity. Mama, wait. Okay, so this is number 1. Okay, heat capacity. Okay, so heat capacity, the definition of heat capacity is the amount of heat energy required to raise its temperature by 1 degree Celsius or 1 Kelvin. Okay, because temperature can be measured either in degrees Celsius or in Kelvin. Okay, so the one in the square also please copy down in your notes as notes number 1 as well. So after heat capacity, the square you copy it down. Okay, so how to find specific heat capacity? It will be heat energy divided by this one. The triangle T is actually the difference in temperature. Sometimes we won't use this triangle T, but we will use this theta. Okay, theta is to represent the change in temperature. Okay, heat capacity. Okay, so you may start to copy down. Okay, while you are copying, I will explain further more about heat capacity. Okay, so just now you have to see already a greater mass and a smaller mass. Greater mass has a greater heat capacity. Okay, why? Because it needs greater heat in order to raise the temperature by 1 degree Celsius. So mass of the object is one of the factors affecting the heat capacity. Okay, so same goes to the type of material. So if you were to use an aluminium, okay, and a plastic, okay, aluminium and plastic, which one you think it will heat up faster, aluminium or plastic? Aluminium, yes, Sim, Alia, aluminium. Okay, correct. It's aluminium. Okay, so aluminium, it needs it will heat up faster. So which means that aluminium has a smaller heat capacity or greater heat capacity. Smaller heat capacity or greater heat capacity. Again, okay. Yeah, aluminium heats up faster. Okay, heats up faster than plastic. So if you compare these two, aluminium and plastic, which will have smaller heat capacity? Okay, same, aluminium. Others? Plastic. Alia, plastic. Other than that? Plastic. Christina? Anyone else? Plastic puna, glass. Hello, no glass, only plastic and aluminium. Okay, okay, the answer it will be aluminium. Remember, okay, why is it aluminium has a smaller specific heat capacity? Okay, when you heat up faster, okay, okay, which means that object need less heat to increase the temperature. Okay, less heat to increase the temperature. When you need less heat to increase in temperature, so which means that you see my specific capacity is the amount of heat energy required to raise its temperature by 1 degree Celsius or 1 Kelvin. That's why smaller heat, lesser heat needed to increase the temperature, we will say that the specific heat capacity is lower. Okay, sorry, it's smaller. Okay, smaller. Yeah, remember, heats up faster less heat needed to increase the temperature. So which means that it has smaller heat capacity. Okay, so if you talk about mass, larger mass, you have larger heat capacity. Okay, if you compare a pot of curry and a bowl, a pot will have a larger heat capacity. That's why sometimes if let's say a bigger bowl of porridge, why you want to transfer some of it into a smaller pot, smaller bowl? Because smaller bowl, it has smaller heat capacity. Okay, heats up faster, at the same time also it will release heat faster as well. Okay, absorb heat fast, it release heat also fast. That's why a smaller bowl of porridge, it will cool down faster than a larger pot. Okay, so same goes to the water in the swimming pool and the water in the pail. Water in the swimming pool, it will be hotter. Okay, it will have a larger heat capacity. Okay, small stone and rock will have a larger heat capacity because it has a larger mass. Okay, so until now we are talking about heat capacity, but our topic today is specific heat capacity, right? So if let's say we are talking about specific heat capacity, okay, this will be the definition. Okay, so if you were to compare the heat capacity, the notes number 1 and this one please copy down as notes number 2. Then the bottom here, the SI unit, also notes number 3. Okay, so the square here, okay, this one together with this also you must copy down as below number 2. Okay, so before you copy down, can you compare the heat capacity and this definition for specific capacity? What are the difference? What is the difference? What can you find the difference between the definition of heat capacity and specific heat capacity? Now, same also Divya, both also got amount of heat supply ma. Heat capacity and specific heat capacity. Correct, okay? Christina is correct. Okay, so when you talk about specific, okay, which means that is representing, it is mean by 1 kg. Okay, so specific heat capacity, when you see the word specific, it is about 1 kg. Okay, that mass. Okay, so the difference between the heat capacity and specific heat capacity, both also is the same. It's the amount of heat required to increase the temperature by 1 degree Celsius or 1 Kelvin. But for specific, we will add it for a mass of 1 kg of the object. Okay, for 1 kg of the object. That's why you see this part. This part, okay, actually, if you compare the formula, okay, for heat capacity and formula for specific capacity, which is this one. Okay, so both is about the same, just that this for specific capacity add in another mass here. So that's why specific is meant by 1 kg of the mass. Okay, so here Q equals to MC triangle T. Okay, is this one T also is the one I change in temperature. Okay, sometimes I will use this theta to represent it. Okay, can Then the mass is kg. Okay, then the C is the specific heat capacity. So how are you going to identify the SI unit for a specific heat capacity? Based on the formula. So as you know, the heat is a kind of energy. So energy, usually we will measure it in what? In joule. Okay, in joule. Okay, sorry, too dark already. In joule. Okay, then for your mass, what is the unit for mass? Just now I have said already. What is the unit for mass? What's the unit of mass? Kg. Yes, it will be So since it is over, so it will be kg -1. Then the change in temperature. Temperature is measured in degrees Celsius. So it is also over. So that's why it also degrees Celsius -1. Okay. So if let's say it's measured in Kelvin, it will be this one negative. Kelvin -1. Okay. Can any problem at the moment? Can. Can I continue? Gayatri. Gayatri. Are you for Alpha Gayatri? Oh, okay. I'm not tell, sorry. Okay. Can you all wait me a while, I'll go and fill up some water Okay, I'm back. Okay, I continue Okay, so the next slide, it will be example using the formula. Okay, Q equals to MC theta to find the to solve the problem. Okay, so Q equals to MC theta. So this one, C is the specific heat capacity, Q is the heat energy, then M is the mass, and this one is the change in temperature. Okay, so we look at example 4.5. Okay, so for example 4.5, okay, so how much heat energy is required to raise the temperature of 3 kg? This one, they have give you the mass. Okay, then from the glass, okay, of a sheet of glass from 24 degrees Celsius to 36 degrees Celsius. This one is the change in temperature they have given to you. Okay, then the specific capacity, usually they will give you unless the question asking you to find the specific heat capacity. So the mass given is 3 kg, change in temperature is 12 degrees Celsius. So you just put into this formula Q equals to MC theta, then you will get the heat energy is 30,240 joule. So joule is the unit of the heat energy. Yeah, Okay, so example 4.6, it will be difficult a little bit. Okay, let's see here. So it has a refrigerator of a mass, okay, 0.4 kg. Must rewrite day and date? No need. This one, because last time I have given you the index already, right? You just continue to write down the notes will do. Okay. Okay. So and the temperature of 22 degrees Celsius. Okay. So what is the temperature of the water after 33,600 joule of heat is removed from it? Okay. So as I said just now, specific capacity not only is the heat absorbed to increase the temperature by 1 degree Celsius, it also can be represented by the heat released to reduce the temperature by 1 degree Celsius. So this is what is the example for. Okay, so they have give you the specific capacity is 4,200. So the question now is they want you to find the final temperature. Okay, final temperature of the water in the ice maker. Okay, so in your opinion, the final temperature will be greater than 22 degrees Celsius or lesser than 22 degrees Celsius? Greater or lesser, since now they are making ice? Hello? Anybody there? Yes, it will be lesser because it releases the heat. Okay, it will releases the heat. So in short, for your change in temperature, okay, change in temperature is actually using your final. Okay, final usually we will use T2 to represent, minus T1. Okay, final minus initial. So from this Q equals to MC theta, okay, Q equals to MC theta, you can, never mind. Okay, Q equals to MC theta, okay, you have the heat already. Okay, you have the mass given, it will be 0.4 kg. Okay, then the specific capacity also they have given to you is 4,200. Then this theta, it will be actually the change in temperature, which means that you use your T2 minus T1. So once you find the value of theta, which is over here, the answer is 20 degrees Celsius. Then you put into this formula, okay, 20 equals to 22 minus, T2, okay, minus the T1, okay, 22. Okay, so the answer, it will be, actually is 2 lah, okay, because usually we will use the greater one minus the lesser one, okay, greater one minus the lesser one. So you use 22 minus 20, you will get the answer is 2 degrees Celsius. Okay, 2 degrees Celsius. Remember, your change in temperature, the value, okay, the value always, it will be a positive value. Okay, it will be a positive value. So always you will use a greater one minus the lesser one. Okay, can get it here? Can get it? Bigger value minus the smaller value for your change in temperature. Okay, can? Good. Okay, so now the next part. Okay, example 4.8. Okay, so for example 4.8, they have given you with a power rating can heat up 4 kg of water from 30 degrees Celsius to 100 degrees Celsius in 10 minutes. Okay, so first question they ask you to calculate the power. Okay, so for how to calculate the power? Okay, actually, okay, since you know your energy, heat energy Q equals to MC theta. So this heat energy, you also have another formula to help you to find it out. It will be Q equals to power times time. Okay, I think you may copy this down inside your notebook. Q equals to power times time. Okay, power times time. So if let's say you want to find example 4.8 question A, so the power, how to find power, it will be Q divided by time. Okay, Q divided by time. So the Q here, did they give you the what? Wait, the power equals to P, P equals to Q over T. Okay, okay, never mind. Okay, so now since you know Q equals to PT, Q equals to MC theta, so you can actually equivalent these two formula. It will be, you will become PT equals to MC theta. Okay, so this is quite a popular formula you can use for chapter 4. Okay, PT equals to MC theta. Okay, So they have give you the T, which is 10 minutes, but you need to change it into second because most of the formula we are using time in second, okay, measured in second. Then the mass is 4 kg, okay, 4 kg. Okay, then the change in temperature, it will be 100 minus 30 equals to 70. So you put into the formula PT equals to MC theta. So this one also I want you to make a note in your notebook lah. PT equals to MC theta. You write beside the formula for your specific heat capacity will do. Okay, so where your T is 600 low, 600 second, your M is the 4, C is 4,200, then times the change in temperature 70. So over here, you move this 600 into the other side, you will get the answer power is 1960 watt. What this one W? W is the formula, is the unit for power. Okay, it's the unit for power. Okay, so B, what is the assumption must you make to arrive the answer? Okay, anything that is related to heat, experiment heat, we must assume that there is no heat lost to the surrounding. Okay, no heat is lost to the surrounding, because if let's say we didn't assume this one, okay, we didn't assume this one, okay, this heat may be affecting our value. Okay, so we must assume this, that no heat is lost to the surrounding. Okay, clear here? Clear? Okay, girls, we still have 4 minutes left. Okay, I don't think I want to continue to start another one. Okay, so now you go out from this meeting, you join in again. Okay, then we will start a second session already. Okay, clear? Go out, come in again, using the same link, same ID, go out and come in. Okay, see you later. Bye-bye.